It's me again, Chanda Cooper, representing the Richland Soil and Water Conservation Districts. Conservation districts were formed in the aftermath of the Dust Bowl in the 1930s to help farmers conserve soil resources. Hugh Hammond Bennett, who is often called the father of soil conservation and was instrumental in the founding of conservation districts nationwide, wrote, "Soil erosion is as old as agriculture. It began when the first heavy rain struck the first furrow turned by a crude implement of tillage in the hands of prehistoric man. It has been going on ever since, wherever man's culture of the earth has bared the soil to rain and wind." Even today, agriculture, home gardening, and development can lead to soil loss through erosion, just as the flower washed away in today's demonstration. Come on out to the field with me to get a closer look. So we're walking up on an area in between a soybean field here on the left and a cornfield here on the right. So this strip of land in between has been tilled. And there are lots of reasons that a farmer would use tillage. It is a strategy that is available to help with weed management. It helps with residue management. So there was sweet corn growing here earlier this year, and obviously it's difficult to plant something new into standing sweet corn stalks. So tillage is a tool in the toolbox, but it does have some consequences. So this soil that has been tilled is much more susceptible to erosion than the soil nearby. It's also more compacted because all the pore spaces, which were the channels and the holes in the soil that would allow it to accept water, all those pore spaces have been collapsed and closed up. So now when the water hits the surface of the soil, it has a harder time soaking in. It's more likely to run off. And of course, runoff can contribute to water pollution. All right, I have my trowel. I'm going to just make a slice, kind of like cutting a brownie out of a pan. And you can see already that it's not holding together terribly well. There we go. There's our soil sample. So I've walked away from the field just a few yards into the woods nearby. The soil here is the same type of soil as in the field. It has the same composition of sand, silt, and clay. The difference is in the organic matter. So check it out. So here in the forest, we have trees and vines, and they have roots in the ground. And there's leaf litter. We get a new layer of leaf litter every year as the leaves fall. They decompose. That contributes organic matter to the soil. It provides food for a really active soil community. I can see right now we've got some ant action happening, but there are also earthworms and beetles and spiders and millipedes and centipedes and all kinds of creatures living in this soil. So it's quite different to what we see out in the field. I'm taking my fingers and just pressing on it, and it gives back. So it's not as soft and flowery as the soil out in the field. This soil, if we think back on the demonstration, this is like the bread. So it has structure, it has those pore spaces, it can accept water, and it's going to be much less susceptible to erosion. Let's take a soil sample and head back to the demonstration area. Trowel again. I'm going to slice out a little soil sample like I did in the field a moment ago, and we'll take it back for a little experiment. So there we go. Soil sample, and you can see right off that really thick layer of organic matter at the top. We're going to perform a quick demonstration called a slake test. I have the two soil samples, the one from the field on the left, the forest on the right, two clear containers which I will fill with water, and two wire baskets. I'll set the wire baskets down into the water and then set the soil samples down into the water on the wire basket. Watch what happens to the soil. Immediately, the soil on the left collapsed. It's eroded. You've got sediment pollution. The soil on the right from the forest is holding together beautifully. So we've seen that increasing the soil organic matter can help protect soil from erosion, but how do we get there? Stay tuned for a few principles that will help you and your students increase soil organic matter, reduce erosion, increase the soil's ability to accept and hold water, and also reduce stormwater runoff. The first principle is to keep living plants and roots in the soil. Plant roots exude sugars and other sticky substances that provide food for microorganisms and help stick soil particles together. The above-ground leaves of these plants will shield the soil from wind and rain, which cause erosion. Go for a walk around your yard, neighborhood, or school campus looking for areas where nothing is growing. Unless these areas are being protected for ground-nesting pollinator habitat, which is important, consider planting wildflowers, grasses, shrubs, or trees. A second principle is to keep soil covered. By covering soil with mulch or allowing natural leaf litter to stay in place, or, in the case of a farm field, allowing last year's crop residue to linger on the soil surface rather than raking it away or turning it into the soil, you'll protect the soil from erosion, retain soil moisture, and keep the soil cool. As the mulch decomposes, it provides soil organic matter and food for soil organisms. To implement this principle at home or at school, identify areas where plants are not growing and add bark mulch, wheat straw, pine straw, or even gravel as a ground cover. A third principle of soil conservation is do not disturb. Each time soil is tilled, soil organic matter decreases as plant roots, fungal networks, and other organisms are chopped up and destroyed. Tillage also stimulates bacteria to very quickly break down any remaining soil organic matter, leaving you with an unhealthy, flour-like substance in place of what was healthy soil. To summarize, the less you can disturb your soil through tillage, the better. A fourth strategy you can use to improve and conserve your soil is to add compost. If you can't grow organic matter in place, you can make it through the process of composting in a bin, such as the one seen here, and then add the compost directly to your soil. To compost, you'll need some sort of bin, such as the one seen here, and compostable materials, such as fruit and vegetable scraps, eggshells, coffee grounds, tea bags, and dead leaves. The Take Action curriculum has instructions for composting as well as a wonderful demonstration to help students learn about composting called Compost in a Bottle. Another way to compost is with earthworms. This is called vermicomposting, and it can be done in small bins inside classrooms. You'll need a container, such as the one seen here, shredded newspaper to serve as bedding, and red wiggler earthworms. You feed them the fruit and vegetable scraps. The worms eat those materials, turn them into worm castings, which are a very rich type of compost, and that material can then be added to your garden or potted plants. Vermicomposting and backyard bin composting are great ways to convert small quantities of food scraps and yard debris into organic matter to improve soil health. But to manage large quantities of compostable material, commercial composting is the way to go. Many municipalities and large institutions, including schools, are working with commercial composting facilities to capture a part of their waste streams, like lunchroom leftovers, and turn them into compost. This compost can then be used to improve soil health throughout the community. You'll hear more about the impact of commercial composting immediately following this video. I hope you've enjoyed learning a little more about soil science and soil conservation, and don't forget those 4 principles you can use to conserve soil at home or on campus. Keep a living root or plant in the soil, keep the soil covered, do not disturb the soil, and add compost. Take care. Bye-bye.